Time-lapses are a fantastic way to showcase your 3D printing projects. They're not just visually stunning but also perfect for highlighting the intricate process of a print, all while saving time for your viewers. In this video, we show how to create jaw-dropping 3D printing time-lapses that leave your audience in awe. Stay tuned, because today I'm sharing everything you need to know to master the art of time-lapse videos. Let's dive in. So probably you would like to change from this to this. Let's start with the tools you'll need. Here's your essential kit for epic time-lapses. A reliable 3D printer. A good camera, DSLR, action cam, or even a smartphone. In my case, Nikon D3300. A sturdy mount or tripod. Time-lapse control software or plugins. In my case, Cura time-lapse plugin. Remote shutter release. Before starting, make sure to set DSLR camera in the correct position. Connect the dummy battery so you won't run out of battery during taking the time-lapse, as we know some 3D prints can take over 10 or 14 hours. Don't forget enough lighting on the 3D printer bed. Set focus of the camera to manual mode, because during the time-lapse, every time we are taking the photo, it's not necessary to do autofocus again and again. Based on the object which you are going to 3D print, make sure all the object will fit in the frame of the camera, then change the aperture, ISO, and shutter speed to have the sharpest and clear image. Next step will be connecting shutter release button to the DSLR camera. In my case, the remote release shutter which I have has double mode switch, which means when you press half it will focus, when you press more it will take the pic. So with some modification I removed the autofocus switch and I have connected an external switch button for taking the picture directly with every hit. Next is to identify dimensions of your 3D printer, which means X and Y axis, how much they can move. In my case, which I'm using Anycubic Kobra 2 Pro, the bed size is 220 mm per 220 mm, which means X and Y axis they have the margin of movement from 0 to 220. Decide where to place the switch button. In this case, I felt more comfortable to place the switch button on my desk and hitting the switch button with Y-axis. Here, I have 3D printed this stand for the shutter switch. As well, I have 3D printed this piece to connect under the bed of the 3D printer for hitting the switch. The next step will be deciding X and Y axis during each photo based on the angle of camera. I prefer to set X axis 220, which will be stick to the end, and also Y axis 220, which will come out of the printer totally, so we won't have any light reflex of the printer bed. Now we have to move Y axis to 220 mm for identifying the exact position of the bed. With Anycubic Kobra 2 Pro, easily press home, which will set all the three axes to 0, then move Y-axis to 220. As we have identified the exact position of y-axis in 220 mm, I have screwed the switch button on the desk. Congratulations, the setup has been done perfectly. Now only we have to modify our G-code for moving X and Y axis when every layer of 3D printing is done. For this step, we just open Ultimaker Cura, go to Extensions, Post-Processing, modify G-code, then hit the button at Script. As we see, there is an option Time-lapse. Here we have some parameters which we should set for our time-lapse. With this time-lapse plugin, after any layer of 3D print, a new line of code will be added to our G-code file with prefix of M240. Trigger camera command. Here we will write down manually G0, which won't extrude any filament. When G is set to 1 means extrude filament, setting to 0 means don't extrude any filament. Space X 220, space Y 220. The next field is pause length, which based on your shutter speed the number of milliseconds stops to take the photo. For me 300 milliseconds is working fine. Then we have parked print head X, we will set it to 220. Parked print head Y, also, we will set it to 220. And we have park feed rate, which will be the movement speed for setting X and Y axis to 220, in general 9000 mm per second will be fine. Great, now let's insert STL file and slice it, then open the generated G-code with Notepad. Look for M240, we see we have found in 240 G0, X220, and Y220 snap photo, then G4P 300 milliseconds, wait for camera. Here are the 2 lines of time-lapse code added to end of every layer of 3D printing. Now let's turn on the 3D printer, we start printing the object, and let's see how will be the results. When the print finishes, you will have the same amount of photos as you have with the layers of the 3D printed object. Easily with any video editing application, you can insert all the photos and generate a video over them. Here we use CapCut for this purpose. Here is the result. Congratulations, you have your first professional time-lapse. I hope you have enjoyed this tutorial. Please leave like and comment and let me know if you have any questions.